In this example, we have a 334 milliliter gas cylinder used in chemistry lab. It contains 5.225 grams of helium at 23 degrees Celsius. How many grams of helium must be released to reduce the pressure to 75 atmospheres? In this case, I would like to be able to use one of the ratios, but the question is, if we want mass or moles and atmospheres, we don't actually have the atmospheres in the first situation. So what do we know? That volume equals 334 milliliters, which is 0.334 liters. N is going to equal 5.225 grams of helium converted to moles. There are 4.00 grams in 1 mole, which gives us 1.306 in our first situation. We also have a temperature, which is 23 degrees Celsius plus 273.15 Celsius gives us 296.15 Kelvin. And so we need a pressure 1, which we're not quite sure. So PV equals nRT. So we're going to solve for pressure, which is nRT over V, which is our 1.306 moles times 0.08206 liters, atmospheres, mole, Kelvin, and multiplied by our temperature, which is 296.15 Kelvin, divided by our volume, which is 0.334 liters. When we solve for the pressure, we get 95.04 atmospheres and our P1. Now, if we remember that P1 over N1 is equal to P2 over N2, we have a P2, we have a P1, we have an N1, and we can solve for N2. So in this case, we would end up with N2 equals P2 N1 over P1. Pressure 2 is our 75 atmospheres times our first moles, which is 1.306, divided by our pressure 1, which is 95.04 atmospheres. We can now solve for that, which is 1.0306 atmospheres. Now, the question asks how many grams of helium must be released. And so we need to solve for how many grams we have in this situation and then subtract. If we multiply that by in 1 mole, there are 4 grams. We get 4.122 grams need to be in this container, and so we need to know how many grams of helium must be released, which is 5.225 grams of helium minus 4.122 grams. In this case, 1.103 grams needs to be released. You could have also solved this a slightly different manner. You could have solved for the number of moles in this situation to where, let me get another piece of paper. Another way to have solved this problem would have been as follows. So if our pressure is 75 atmospheres, our volume is again 0.334 liters. Our temperature will be the same at 296.15. The N is a question mark, and we already know what R is. And so PV equals nRT. So we're going to solve for N, which gives us PV over RT. In this case, we have 75 atmospheres multiplied by the volume, which is 0.334 liters, 0.08206 liters, atmospheres, mole, Kelvin, multiplied by our temperature, which is 296.15. Now we can solve this. 75 times 0.334 divided by 206 times 296.15. So we get that N is still equal to 1.03 moles. And so now we would need to subtract the two. So we could again convert this to grams. Which would give us 4.123 grams of helium. And so we would subtract our 5.225 grams minus 4.123 grams, which would give us an approximately similar answer, 1.102 grams. And so based on sig figs, we would end up with the same 1.1 grams of helium released. Both ways would give you the same answer, and so it just is a matter of how you want to solve for that.